talk about continuously compounded interest. It's a lot like compounded interest, but instead of having it be compounded monthly or biannually or quarterly, you have it compounded continuously, okay? So that means you use a different equation. This continuously part implies we use this equation. If we just had compound interest, we would use the other equation that we did in the other video. But whenever it's compounded continuously, our number E, Euler's number, gets utilized. So let's say that we had a similar situation to the video before. Our principal amount invested, P again, is equal to $8,000 again, and the rate is still at 8%. Let me fix this error here. 8%. Next, we wish to know, okay, last time we did it compounded monthly, and we just realized that we got like 12,680.84. 12,160.84, my apologies, 12,160.84 cents. So now we're going to see what is it compounded continuously at 8%. Which one is superior? Okay, so at t equals 6 years, t is equal to 6. What do we have going on here? Well, the amount that we'll have after 6 years is the initial principal amount, 8,000, times the number E raised to the 0.08 times 6 power. Recall, we alter this percentage for the interest rate. It's a percent, so you have to divide it by 100. Whenever you do so, we then calculate what this is equal to. We get this is equivalent to 12,066.60. Okay. So this is how much it is compounded continuously. Okay, we'll fix this right here. This is how much we get compounded continuously. Now recall, just compounded interest had this formula. The amount is equivalent to the principal times 1 plus the rate divided by the number of times compounded per year raised to the number of times compounded per year times your t. And last problem, we had compounded monthly, so n was 12. Next, we had the principal amount the same, $8,000. Okay, and then the rate R was at 8%, and our time was 6 years again. So whenever we do it like this, this is equivalent to 8,000 times 1 plus 0.08 divided by 12 raised to the 12 times 6. And if you remember last time, this was equivalent to 12,160.84 dollars. Okay, dollars. So it is apparent that at least for 6 years in interval, it is better to have the compounded monthly versus the compounded continuously. You'll get about $100 more doing it where it's compounded every 12 times every month, once every month. And so as you can see, knowing some mathematics is very good for the pocketbooks, because for those of you who might want to go work in finance, this will allow you to invest the value of your money in various forms more tactfully. Furthermore, it's good for anybody because now you can know what the banks are offering and predict how much you will get in the future for your interest.